secure software development lifecycle. My name is David Kosorok, and I'm looking forward to having a discussion with you about things you might need to succeed in an agile CI/CD environment from an application security perspective. Now, I kind of want to briefly go through an agenda. I'm going to talk about who I am, how we can be in the application security world partners, not pariahs, with our development friends. We'll talk a little bit about where do we start, how do we keep going, when does it end, and then hopefully if we have a few minutes, we'll have a little bit of Q&A at the end. So I started my career as, I'm currently the Director of Application Security at SAP Concur. I started about 20 years ago in software testing specifically, and then it kind of morphed into security testing when I had one of those aha moments as a benevolent tester from outside the company called me and said, hey, I found a problem here and it looks like I can own your server. And I wanted to find out how that happened. And so I actually quit my job as a software test manager and started a new group that focused on application security because of that. I'm the father of 9 kids. I'm still married. I'm coming up on 30 years. A few of the initials at the end, CISSP, CSSLP, GWAPT, others. I just recently, last year, finished my master's in information security assurance. I've been working as a beta editor for PenTest Magazine for a number of years and enjoy that. It's an opportunity to review articles that are being presented for the magazine. Oftentimes they'll ask us as ghost editors to write articles as well, which is a great time to learn new subjects. I love reading sci-fi fantasy novels. I like trying to write. One of my new projects is trying to figure out how to write for an audience that's the same age as my children. I'm an enthusiastic glamper. That's where I have a big tent, a cot, pad, a sleeping bag, and a pillow. And that's how I camp nowadays. And yes, I used to ride a unicycle, from a 1-foot unicycle to a 6-foot unicycle that I could mount in the middle of the basketball court without any help. That's kind of who I am. I love application security. So moving on to our subject, I've worked with developers in various capacities over several years. And when I approach a team and offer services from the application security team and say, hey, I'm here to help you, there's usually an eye roll. And there's just that common misperception that security is there to block progress of all innovative good things, squash innovation, crush your soul or whatever, and drown the dreams of every developer. And sadly, many of these misperceptions are based on old school security teams running static or dynamic scans, then throwing the results over the wall and saying, here, developers, fix it. And if you don't fix it, really bad things will happen. So they cause a lot of panic. They cause a lot of fire drills. And so developers have to stop everything, stop their creative process, drop everything, and then jump into this fix-it mode for a few weeks, and then they go back into their regular job and can ignore security. And that's, unfortunately, that's not really a great way to integrate security into the software development lifecycle. If you treat it as something as an emergency, it's never built into the process. It's never part of what you do. It cannot be a one-off fire alarm. And realistically, there are so many better ways to integrate security into this life cycle. And I kind of want to hopefully go through some of this process. In today's fast-moving agile development cycle, the security has to be that pillar. It can't be that gate that we keep seeing and being sometimes, unfortunately. We have to find a way to support development in their process of developing a great experience for users. And security can be a partner with that. And so looking at ways how to integrate into the existing software development lifecycle of a developer without having to take a whole new process and plop it on top and erasing what they have is usually the best way. We want to find also ways that we can ensure that we eliminate what I call tribal education, and that's where it's absorbed by accident from others that have been there a long time. We want to have really precise processes, precise processes that allow us to get clear communication to these teams in a consistent manner. Hang on just a second. So, focusing on this pillar idea and not a gateway, becoming a partner, not a pariah, is something that it should be ingrained in the security culture of every company we work at. Okay, where do we start? How do we start this great security culture and become partners with our developer friends? First step is creating, and again, this is from my perspective, creating a solid application security program. That means that we have the ability to cover basic requirements that are regulatory requirements, such as PCI DSS, HIPAA, or FISMA, any of these that come our way. We want to make sure our program covers and we can deliver the evidence needed for auditors, but we're also covering the large gaps of risks that we have with our applications. In order to do that, we do need to understand the existing software development lifecycle that developers are using, and then start looking for ways to integrate within that. Because at the end, we have to reduce that fire hose effect that occurs when we cause a panic or pull the fire alarm. We really need to find ways to integrate and start with a few core processes and ensure that what we integrate is something that the development teams can actually do and accomplish. A lot of times, and I'm sure many of you have experienced this, where we come up with this great plan and we have 100 controls and we say we're going to do these all at once. And as we do that, we have to ensure that my apologies. We want to make sure that we are maintaining a tight control of what we ask our developers to do. If we give them all of this stuff, nothing happens. But if we give them a couple things that they can accomplish and do, then great things will happen. And we'll see that level of cooperation significantly. And so let me kind of start with an application security program. And this is an example of one that I've created with our team that we've grown and evolved over time. But this is kind of the full program. It really does start with creating security champions. And I apologize if the text is so small. I'll have more detailed notes on this that will come with the presentation. But the process is find a security champion. This is a role that's within each Agile team of a developer that takes on an additional role of helping to drive threat modeling or static analysis or the other processes that each Agile team needs to go through in order to complete the application security program. These champions also will help drive the threat modeling as they review their product and they begin to assess where they are, what the risks are, where the attack surfaces look like, and who the actors are, and so forth. These individuals will play that integral role, and they'll begin to develop a good process on how to attack their own product. Moving on from that design, kind of the design phase process, they'll begin to look at their source code as it's developed and run static analysis. There are a lot of great tools out there, and I'm not personally endorsing any tool in particular. I can just say that I have used. Well, it's Micro Focus Fortify now, but check marks. There's some other static tools. Looking for a static analysis tool that has an API that you can work with and automate is very, very important to be successful here, I think. And I'll kind of go into that more in detail later about how we need to integrate into that pipeline that developers use, that's the SDLC. Having a good security training program is very important. This covers the aspect of not only your annual required security training, but also quarterly training, where you may pull in together a group of developers that have shown a keen interest in security. So you pull that together and you say, okay, this is a group that anxiously wants to learn and listen. And so you may develop more specific subjects that go a little bit deeper on writing secure code. Maybe even showing examples of code or vulnerabilities that you found within their own code that allowed you to get shell in the box. And so you can show them that example and how it was remediated and how it's no longer possible. So they get a good understanding of the whole flow of where a hacker could come in and do bad things, and then how that can be mitigated. Open source SaaS is an important concept that you need to be continuously looking at. As you use these sometimes free and open components out there, you have to be aware of the security vulnerabilities that any version may contain. And so being aware of that and running that within your software development process is an important aspect of the program. Once the static analysis stuff is done and you begin to build and deploy, you want to also run additional testing on the dynamic or executing code. And you know, we use multiple tools for that. You can proxy through Burp Suite Pro. You can run Web Inspect Enterprise. You can run multiple tools that do that. And one of the things that we found that was interesting, and we just have started using this and experimenting with this just in the last couple of months. So you have SAST, which is static analysis, DAS, which is dynamic application security testing, and then this latest one that's been around for just a few years is IAST, which is the interactive application security testing. And that's really an interesting tool where it's actually instrumented into the deployment build. And as you run specific tests, only those areas that you're executing a specific test against will kind of spider off in a very controlled, scoped area and run the security test for that area. And so that reduces your time from potentially taking days or even weeks if it spiders through an entire web application testing and running tens of thousands of tests against those areas to just that narrow focused area where you have had a change. And this can be used with DAS. So you may still want to do a monthly dynamic scan, but you want to get closer to the developer. And so running this IAST scan allows the developer to get very quick feedback on what they've just deployed. Similar to when you run static analysis and you give them feedback in less than a day, as opposed to waiting sometimes for weeks or months again. Giving them quick and often feedback is something that is very, very important for a successful relationship with developers. Okay, so manual reviews are all part of that as well. I kind of had that in the process. API fuzzing is something that we're just now bringing on board, where you are able to continuously test an API, and you fuzz through this continuously until you find those unhandled exceptions that pop up that are, and you know, this is kind of the zero-day stuff that hackers are looking for. And API fuzzing is another one of those areas that kind of fills that gap. Of course, the compliance requires that we do third-party pen tests annually, biannually, and we always look for companies that will find great stuff. We don't look for the check mark. We look for the companies that will help us find things that we haven't found before. Now, hopefully, with all this other stuff that we've done before, that number is not very high, but we want to look for that ability to dig a little bit deeper. Having a red team in the military, you have a red team and a blue team. Red team is attack, blue team's defense. A red team in the cyber security world, of course, is a great tool to use for a number of reasons. Number one, you can use it kind of as an attack dog to show executives an example of a particular vulnerability and what the risks are by going through a full execution of the process and getting shell in the box or something for a particular vulnerability to say, hey, this is why this needs to be fixed in a more timely manner. Or you can use it to create stronger levels of cooperation and collaboration with teams outside of the security team. The hosting team, for example, could help with a red team attack, those kind of things. And so you begin to develop a stronger security culture. Then also you have tools that are lesser known, maybe lesser used, typo squatting types of tools. This is where you're looking for URLs from domains that bad guys maliciously created that are similar to yours, but maybe have a typo in it. You know, a 0 that replaces an O or something like that. And the idea is to steal your customer's credentials by developing a website that looks very much like yours, but it is intended to grab those credentials. And the idea is you can report this information back to the browser owners that can then block that. You can also block it from your customers. If you're in a cloud organization, you can block your customers from accessing those sites from your site as well. SSLLabs.com, of course, is another control that's a free and easy control out there that a lot of customers will use to kind of do a quick little check against your domain and say, does this company configure their stuff securely? And it gives you a letter grade, and a lot of you are probably familiar with that. But we wrote a simple tool that will just scan every Monday and give a quick report. And if the grade falls below a certain level, we log a security issue and assign it to the team that owns that hosted environment, and we ask them to fix that configuration problem. And you know, sometimes things will fall through the monitoring that are not necessarily a serious security issue, but to customers they're like, oh, that looks kind of sketchy. So this kind of helps catch some of that. Another control that we have is called an external DAST, or an external dynamic application security testing, where it's continuously scanning for vulnerabilities against your site, but it's from outside of your own corporate environment typically. And so it's scanning from an external perspective. And this is a good thing to have because, again, that continuous testing, as we deploy and move into that CI/CD range where we want to be deploying more than once a month, more than once a week, more than once a day, sometimes 10 times a day, we have to be able to continuously scan our environments. And it's nice to, again, have that third-party perspective that's outside that range of our own internal corporate tools. And then finally, the control that we have found to be one of the most valuable is this responsible disclosure tool called Bug Bounty. And that's where you invite security researchers to come and attack you. And we do it in a couple different ways. We have a private Bug Bounty program where we invite security researchers that are the top of the program to come in and attack our system, and then we pay them for finding great issues. We also have a public responsible disclosure program, public bug bounty, which anybody can join and report their issues, and they get on a leaderboard and they get points and so forth. And usually the ones that are the top tier producers of issues there, we may invite them to the paid private bug bounty program. The public one allows us as kind of a cool catch-all that if a customer says, hey, we want to test your program before we buy it, we'll say, hey, you know what, join the bug bounty program, look for bugs, test it all you want, and report them to us, and then that gives them that legal license and scope to attack our system within a reasonable level. You know, we don't allow a denial of service and other things like that, but you know, we give them a very specific scope. So that's an application security program that we have developed, and I've used this over time, and it's something that it works well. You can't give this to developers all in one plate, and that's where their hair catches on fire. You have to be careful about that. Okay, let's kind of take a little step and look at what our developers are doing at a very high level, and where they came from, where they are. You know, we are all familiar with the old waterfall technique, and you know, where you implement security processes were very rigid here. Well, there's ways to integrate this, obviously, in the agile process and the Scrum methodology, or any of those kind of things. It's very easy to integrate security into those processes. And whether you use agile, CI/CD, DevOps, whatever flavor of methodology your development team is using, that gives you that opportunity to interact with your developers, and knowing what they're doing allows you to plan for how you're going to implement particular and specific application security controls. For example, in the CI/CD world, we know that they're going to want to deliver multiple times a day. That's their end goal. And so running a dynamic scan that takes several weeks to run is not practical. You have to be able, maybe the IaaS scan, where it's very short and specific and quick, gives you and covers that risk enough that will give you the confidence that control will do what you need. Giving the developers the ability to run their own scans within their pipeline is very important in that environment as well. So understanding their environments and knowing how you as an application security expert can help them and work with them is very important to be successful in this arena. Now, all of these things that we talked about are important. Developing that relationship is important. We want to avoid, again, like I said, the fire hose effect. Now, finding the appropriate integration points. I just kind of really hit on that briefly. Find out where you can implement the threat modeling, and that discussion, that important discussion, as the architects and developers begin to plan and develop something that they create, the larger scale stuff. Interestingly enough, there's also agile threat modeling, which is where you ask, instead of going through a large multi-day process for threat modeling, maybe it's 4 questions that you ask about the data, kind of data, how it's used, where it's stored, that kind of stuff. So understanding where and when and how long and to integrate is very important for this. And then starting off with implementing just the core process. What's the bare minimum that you can implement within an agile team and get that you want them to be doing continuously? Now, because it's agile, you can obviously add more as they get used to running scans nightly as they merge their branches, as they think about deploying and running dynamic scans, those kind of things. Once they get in a rhythm, that's when you can kind of inject another control and find out where that balance is. Now, at all times, you're there to help balance out, to ensure that the teams aren't going crazy, but you're balancing out and ensuring that good security practices are indeed happening, as well as great controls, specific controls, well-defined controls are being implemented. And then in all times, you want to make sure that when you implement these controls, that you train the developers specifically. You don't want to have them run a static scan on their source code, and then you'll say, okay, there's your scan, and you walk away and leave them with 80% false positives. You want to work with them and make sure that that is a very clean plate, that you help them tune for their particular team the scan, so when you walk away, they know that when a finding appears, it's very likely going to be something that they're going to want to act on. You don't train them to ignore the tool by leaving all those false positives or things like that. And then, of course, like I said, you can add to this a bit at a time. And that all will help with reducing the fire hose effect. Now, here I kind of was experimenting with trying to create a priority order for application security controls, and the security champion, threat modeling we talked about, security architecture review board. This is another thing where you may want to have the teams go through a larger review board where you have security experts that are giving opinions on specific designs that are happening. That, of course, needs to again be also leveled at an agile team focus. Static analysis, we talked about. Security training. Those are the core things. External DAST, bug bounty programs. I kind of want to put my bug bounty program up for. We found that the value of that was so high. We were getting findings that were very valuable. And then, of course, for a great bug bounty program, you're initially paying out a little bit more money, but as time goes on, as your developers fix stuff, and you get into the rhythm of them understanding how important it is to fix something when you first find it in the static analysis, otherwise the expense of fixing it in production is 100 times more. They kind of get that idea when we're through a bug bounty program. But this is generally an idea. This is, again, my opinion of the order that I would implement things in and how I would kind of trickle into the team. So again, my opinion only, but that's kind of has worked for our team. Now, once we have this in place, a big part of what we want to do is how do we develop this process that we keep going and keep this rhythm going of great security and great collaboration with the Agile team. And a big part of it is continuously training. Now, we have a couple different ways to do it. We offer at a very high level for those that are most enthusiastic about security. We may offer a SANS.org course. We may say, hey guys, you're doing such a great job. We're going to give you this GMOB course or something where they can grab it and get a certification on that helps them and builds up their resume. Maybe we want to just say, hey, we found this problem here with XML entities, and let's walk through that process, and you walk through the team on an issue that you're finding. Micro trainings, and this is where we'll find a security vulnerability that keeps popping up for a particular team or product. And so we'll create a 5-minute video and say, hey, this is how you find the issue. This is how you get shell on the box by exploiting this issue. And this is how you mitigate the issue and how it can stop that. And so in a quick 5-minute video, you can drive home to a developer the importance of ensuring that this particular security vulnerability is not written in the source code. CTF games are a great way to increase your security culture in your company. This is where capture the flag games are commonly used to introduce new security principles to teams that have never been exposed to this level of security before. And it's in a gamified way, so it's really entertaining. And there's a lot of ways you can do that's training that's not, I mean, the things to avoid are any training that's over an hour long. I think you're going to lose a lot of developers. Training that's more 5 to 10 minutes is going to be something they're going to listen to and pay attention. I think gamifying it, challenging them, rewarding them are all things that help keep that process, the growth of security culture going. Making small changes, not throwing the entire collection of every control you can think of at the developers, but start with a few ones that you know are going to have a very, very high value, like static analysis and threat modeling. And then, of course, you really need to find ways to decentralize. And this sounds like I'm kind of talking myself out of a job, but looking at the things that you do for a team, where you go in and you run static analysis for them. Well, if you have that tool embedded into their pipeline and they can run it, they're going to take security more seriously than ever before because they're owning it all the way. And so finding those things that can be automated, where developers can be involved directly, is very important. And understanding that there's some things you cannot divest from your team. You have to have some manual testing. You have to have investigation. That's one of the points here, in fact, where as a team, instead of running static analysis, you're researching, looking for the future things that you can bring higher value to the development teams. And that's where the development teams get the sense that you're evolving along with them. And that's a very important process of security. And then, of course, like, have a security culture, have a very specific, where you say, hey, annually we're going to meet together and do this summit, or monthly we're going to meet together and talk about these cool security processes. And you develop a pattern and a cadence that works with the teams. So again, I'm going to go back to the process of developing a security culture as a pillar. And I've taken these security processes that I've already talked about and kind of divide them into 3 different pillars of communication, education, and collaboration. Communication, those are the controls like the security awareness, training collateral, threat response, security engagement, knowing how we can interact with the developers to increase their awareness. Educating, of course, is more focused on how do we coach the security champions to be that great security representative for their agile team and to do the process that we're asking them to do. Engaging, working with developers to teach them the best practices. Tabletop exercises, that could be CTF, that can be other things where we go and show them very quickly why a security issue is dangerous and what the risk is and what the value might be of fixing it. Security summits. This is where you invite engineers, of course, to participate and learn about very specific security-related subjects that are specific to their product, to what they're working on. Quarterly company training is another area where you have an opportunity to teach general subjects. Collaboration is where you get together as a group, and security and architect and designer and PMs get together to talk about what they need to do to improve these processes and how to adopt security at a specific rate. The Security Architecture Review Board is another one that's very collaborative. Red team and blue team, where you have that ability. CTFs as a team, you can encourage people to get together as teams and create teams to do those kind of games too. And then, of course, agile software development lifecycle, as we've been talking about, is very important for the collaboration, where you have the security champion role, where you have the security mentor come in, and you work with these teams to develop that great culture. Now, kind of the last question to ask after going through all of this process that we've just discussed, and it's kind of a one-way discussion. I'll have an opportunity for questions, of course, but really, you think, when does this end? At what point can we say, okay, we got to retire the security team and move on? And the reality is, it never ends. We are locked in for life with these jobs in security. The bad guys are going to want to get our stuff. The nation states will want to get it. Organized crime wants to get it. If you are producing something that someone's willing to pay for, someone else wants to get it for free. And so our job is going to be moving along without end, as far as I can ever see. But I think we need to find ways to embed ourselves with developers and ensure that we have an end-to-end coverage, that we are with them from the beginning of the development of their product to the end, to the time that they retire it and move on to something else. That they know that we're there, and that they know that the information they have at hand is the latest and greatest information, and that we are doing our very best to protect them. And with that, I want to leave that open for you now with any questions.